Okay, so we were talking about the object model at the end of the last lecture. So why are we here? So let's just jump ahead quickly. Oh, here we are. Here we go. Okay, so this is where we were at the end of the last lecture. So we know that object-oriented programming, you focus on decomposing programs into separate objects, right? So the objects become the components of your program. Each object has information that it can act on, and it has methods that will other users can use to operate or to ask the object to perform some action. In object-oriented programming, we talk about four main aspects in what's called the object model. So there's these four terms here. So I'm going to describe the first three terms to you now. Term number 4, that's for part 3 of the course. So here's a quote from a very well-known textbook on object-oriented programming. So it's object-oriented analysis and design with applications. It's a famous reference book. It's not really a textbook on related to object-oriented programming. So the author says that abstraction is one of the fundamental ways that we humans cope with complexity. An abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of objects. Right. So right away that sounds like types. Right. You've got an object that has a type, right? And its type is different from other kinds of objects. So you can have a string type, you can have a list type, and so on and so forth. And thus provide crisply defined conceptual boundaries. And then there's this other term here relative to this perspective of the viewer. And so I'll explain that term momentarily. So let's go back to the first part of his definition, where he says that abstraction is one of the fundamental ways that we deal with complexity. So you can think of when you make a class in Java, whoever creates the class often has a fairly difficult job to do. Right? So you can imagine that whoever created the class that lets you print something to the screen, if you actually look at what's involved in printing something to the terminal on your computer, it's actually quite complicated, right? So if you use the debugger to trace through print line, just to print out an int, right? You'll end up going through many methods in many different classes, right? So it's not just system. So it's not the system class that actually defines the print line method. It's some other class. And that other class class needs to call methods that are in other classes, and so on and so on and so forth. But using println is very easy, right? System.out println, and then whatever you want to print. Right? And so that's what he's trying to get at with this first part here. Creating classes lets you build abstractions, right? Yes, it might be hard to make the class, but anybody who uses the class should have an easy way, right? Or it should be easy for that user to use the capabilities of the class, right? And it's similar to lots of things in real life, right? So when you drive a car, you step on the gas pedal, the car goes faster, right? It's pretty simple. It's pretty straightforward, right? If you can drive a car, if you can drive a automatic car, right, a car with an automatic transmission, you can pretty much drive any other car with an automatic transmission, right? Step on the gas, car goes forwards. Step on the brake, car slows down. Turn the steering wheel left, car goes left, right? Pretty straightforward. If you actually look at what's involved when you step on the gas pedal, it hides an incredible amount of complexity. So that's what building abstract. So in object-oriented programming, we try to build abstractions. Our abstractions are classes, right? Or one form of abstraction is a class, right? That class can hide lots and lots and lots of complexity, right? But it should be relatively easy to use. Now, what's this relative to the perspective of the viewer part? So when if you were to make a car class, right, you have to ask yourself, why am I making this car class, and who's going to use it, right? So that's the relative to the perspective of the viewer part, right? So if you make a car class when you're trying to, for example, build a website where you're trying to sell used cars, right? Then your car class is going to be very different if you're building a car class for a video game where you're driving around in some 3D world. If you're trying to sell the car, you care about things like the make and model, the year, and so on and so forth, right? The price. If you're driving a car around in a 3D video game, you're interested in very different things. Right? So in other words, you don't make a car class that can do everything for everybody. When you make a car class, you have to decide who's going to be the user, right? And what features do they need in order to use the class effectively. Okay, so that's the idea of abstraction. Now, encapsulation is related to abstraction, but it's not the same thing. So encapsulation is the process of compartmentalizing the elements of an abstraction that constitute its structure and behavior. Right? So right away in Java, right, encapsulation looks like making a class, right? So it's the process of compartmentalizing the elements of an abstraction that constitute its structure and behavior. So everything you need, so for example, let's use the string class, right? Everything we need to make a string class and to use a string class, or to make a string object and to use a string object, right? We put that into or we compartmentalize, right? We put that into a central place, right? In other words, we put it into the string class, right? The structure of a string, right? So the characters that are in the string, right? We put those in a single place. Its behavior, right? So the methods that can operate on the characters of a string, we put that in a single place, right? So in Java, this looks a lot like making classes. Encapsulation serves to separate the contractual interface of abstraction and its implementation. Okay, so what this means is that, so the contractual interface, right? So that is saying, for our purposes, that's what does the class, right? So that's what the class promises to do when you call one of its methods, right? So every time, so when you look at documentation for a Java class, right, every method has a specification, right, a description of what it does, right, or its contract. So every method says these are what you have to. This is the information it needs, right? The parameters. This is what the method will return if it returns anything. And this is what the method promises to do. Promises to do, right? So that's your contractual interface, right? The implementation, right? That's how the methods are implemented. Okay, so by putting things into a class, you can by putting things into a class and by using interfaces, right? You can separate what the methods are supposed to do, right, from how they actually do it, right? So in other words, anybody who's using the class, they just have to look at the contract, right? How do I use the string class? Well, I just use, I look at the constructors, or I look at the documentation for the constructors to find out how to make a string, and then I look at the documentation of the methods to find out how to use the methods, right? But I never need to know, or I never need to directly interact with the information that's inside the string, right? So in other words, I don't need to know that the string is an array of characters, and that I can go. I don't need to know that the string is a plain old array of characters, right? And I don't have to manipulate that array directly, right? So its structure is hidden behind the interface of the class. And finally, there's modularity, which is related to encapsulation. Right? So modularity, that's the act of partitioning a program into individual components. So again, that looks like, hey, we're making classes, right? But that's just one form of modularity in Java. Right? So you're gonna take your program, you're gonna split it up into individual components. So classes are certainly make up the individual components of a program. Right? But you can think about your program in larger terms, right? So in other words, we can take all of our classes and group them into packages, right? And then there's actually another form of modularity in Java that we don't talk about in this course, but you can actually group the packages into things called modules. And you can control which packages can see which other packages using this module facility in newer versions of Java. Right? Now, why do we do this? Right? Because it makes your program easier to understand. So if you had, for example, 1,000 classes all in one place, right? So all in one package, it becomes very unclear it becomes very unclear what the relationship of those classes are, right? So what classes do what? I don't know. They're all in the same package, right? If you look at the Java standard library, right, its classes are separated into individual packages so that so it becomes more obvious what the relationship between classes are, right? All the fundamental classes are in java.lang, right? All of the collection classes are in java.util, right? Anything that deals with I/O is in java.io or java.nio, something like that. And so this is very useful when your program starts to become large, right? Because now someone who has to look at the program and try to understand how it works, right? That gives them that gives them an easier way to accomplish that task. Right? It's possible to create a very, very large Java program with just a single class, right? But trying to understand that class becomes extremely hard to do. So so we often break classes down into smaller components. And in fact, a lot of the time, the components are actually quite small. So it's not unusual to see large Java programs made up of many, 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 many different classes, right? Each class has its own very well-defined specific purpose. And that makes it much easier to understand a program compared to putting everything that you can think of into a single place. So those are the three main terms that you should keep in mind as you go through this course. Right? There's a fourth one that shows up in part 3 of the course, and arguably there's a fifth one. And that one shows up in part 4 of the course. Okay, so that's the I guess that's the theory behind creating an object-oriented program. Now let's look at the actual creation of a Java program. What would be the purpose of having multiple classes if your program is small? Yeah, so if your program is very small, right? So for example, so look, even in assignment 1, there were 3 separate classes that you ended up using. So assignment 1 is only 200 lines long in total, roughly, right? So would be considered a small program, but it's already split into 3 separate classes, right? So the purpose of having multiple classes is that you want your program to be easier to understand, right? You want your classes to all have a single well-defined purpose. So you want to avoid making a class that does everything for everyone, right? Whatever everything and everyone means for your program. Okay, now so what does an actual Java program look like? So you know that it's going to be made up of a bunch of classes. And so here is showing you a program that's made up of one or more classes. Now, typically in a Java, every Java class goes into its own file, right? So you saw this already in your labs and in assignment 1 and assignment 2, if you've started assignment 2, right? You know that every class that you create goes into its own separate .java file, right? Inside one of your source code files, right, at the very beginning of your program, the first significant line of code is a package declaration, right? But it doesn't have to be there. So you are allowed to create a class that is not in any package. So there's 0 or 1 package name. Right? So every class belongs in a single package, or it belongs in no package. Right, so that's the first significant line of code. Right, that's the first line of code that's not a comment, basically. If your class needs to use other classes, then you have to import those classes. Right? So let me back up. If your class needs to use a class that's not in this yellow package here, then you have to import those other classes. class doesn't need to use any other class, then there's no import statements. And then finally, there is the actual definition of the class. That's down here. So that's the third main chunk of a typical Java class. That class, you can define one or more fields, which are also called class variables. So these are just the variables that make up the information that every object is going to have. You're going to have 0 or more constructors. So whenever you write new blah, you're calling it a constructor. Who defines the constructor? Well, the class defines the constructor. So typically you'll see those next. And then finally, how to use an object? Well, normally you call a method, right? So after the constructors, typically you'll see 0 or more methods. And that's a graphical picture of what a single class looks like, right? And then of course your actual program is made up of multiple classes. Now this is the this is the organization of a typical simple and small Java program, right? It's actually much more. Sorry. So here's a picture of a single class, right? Now don't worry if you don't understand what's going on in this class, right? This particular class implements a data structure called a stack, right? If you've been reading the notebooks, you've probably encountered this thing already. So in the notebooks, it describes exactly what a stack is and where you might use it. If you haven't gotten there, don't worry about it, right? This is just showing you what a class looks like, right? Package declaration, right? First, second, any import statements that are required. Third, the big blue box, that's your class definition. Inside the class, right? There's a field, there's a constructor, and there's 4 methods in this particular class. Okay, so that's a picture of what a typical class looks like. Now, it's actually much more complicated than this. So the Java language it's larger than what we can cover in a single introductory course. So it turns out there's lots of things that you can put into a class, and there are different ways that you can organize a class that's not shown in this picture here. So there's all of these features, right? Most of which we're not going to get to, except for this one. So later on, you will see a class inside of a class, right? But for now, our classes they're all standalone classes. So in other words, a class is not going to appear inside of another class, at least not for a few weeks, right? You can even put a class inside of a method, which seems odd, but it turns out it serves a very useful purpose in Java. That's related to the next one. So an anonymous class is a class without a name. And again, these two things taken together actually serve a particular purpose. There are these things called lambda expressions that were introduced in Java 8. There's not enough time to talk about those. We'd have to throw out one of the major components of the course in order to talk about these. Modules, that's a facility that Java 9 introduced to help you organize very large programs. Right now, we never make a very large program in this course, so this isn't especially useful. If you ever go out into industry and work on a large Java project, at least a modern large Java project, if you're working on a very old one, you won't see these. But if you work on a modern large Java project, you will almost certainly see the modules. Right. If you hit this link here, that takes you to the official Java tutorials, and it talks about it gives you a very high-level overview of a lot of these things. Okay, so packages, right? The first thing in your class is often a package declaration, right? Packages are just used to organize your Java classes into what the language specification calls namespaces. Right? So I guess the easiest way to think about this is you want to organize related classes into the same package, right? So you want to put them in the same place. So for example, back here, right? If you look inside the package CA Queens U CS CISC 124 Notes Basics, right? You'll see all of the you'll see several small classes, and these are all the classes that are used to to introduce objects and classes in the course. Right. So you'll see a few simple classes. What's their relationship? Well, they're all relatively simple classes that are used in the introductory part of the course. So the standard says that you use packages to create what are called namespaces. So the obvious question is what's a namespace? Right? So a namespace is just a container for names. Right. So in other words, you can think of a package as just being a folder, right, or a directory, if you know what a directory is on your computer. So it's just a folder. You can put classes into that folder, right? But you can also put folders in that folder, right? So the folders are all other packages, right? So the namespace has a name, right? So this is just a container for names. So CA, right? That's the name of a container, right? What can I put in that container? Well, I can put in Queen's U, right? That's another package, right? Its name is Queen's U. I can put the CS package into that package. I can put the CISC 124 package into that package, and so on and so forth, right? You can also put classes and interfaces into a package. It's just a way to partition your program, or it's just a way to group related classes and interfaces together. So all of the Java standard library classes, they go into a package called Java. Inside the Java package, there are other packages. So there's a package called lang, there's one called util, there's one called IO, and so on and so on and so forth. Right? So when you put a package into another package, right? So when I put the package, lang into Java, right? What's the name? What do I now say the name of lang is? Right? So the fully qualified name of a package, right? It's just all of the packages grouped together, right? So whatever package lang is in, you stick that in front, right? Lang is in the Java package, so it's the full name of the lang package is java.lang. Java.lang is the fully qualified name, package lang. Right? Java.util, that's the fully qualified name of the package util. Fully qualified name is just all of the packages stuck together, joined with the period. Inside of a package, you can place classes and interfaces. Right? So I can put the object class you would find in the package java.lang. Right? The string class you would find here, the math class you would find here. Right? Just like packages, classes also have fully qualified names. Right? So object, its full name is actually Java lang object. Right? String, its full name is Java lang string. And math, its full name is Java lang math. Right? You can always use a class in your program by using its fully qualified name. If you use its fully qualified name, you don't have to import the class. So but if you don't import the class, then you have to use its fully qualified name. And this gets, you have to type a lot. So this becomes very awkward. Now, what is the reason for having packages, right? So why am I grouping classes together? So one reason is to group classes, right? To group related classes together so that you can more easily understand the structure of your program, right? But the main reason for doing this is that the language needs a way to make sure that class names are unique, right? So you can imagine that in a very large program, so you have lots and lots of classes, right? So you might make many of those classes yourself. But you're probably, in a very large program, you're probably going to go and get someone else's code to use, right? So in other words, you're going to find someone else's library of classes that have been created for a particular purpose, right? And you might want to use those in your program. Now, because someone else made those classes, you can't control what they named those classes, right? So there's a pretty high chance that there's a non-zero chance that they've created a class that has the same name as a class in your program, right? And that becomes a problem because now the compiler can't determine. So if there was no way to make sure that class names are unique, then there's no way to tell what class. There's no way to distinguish between the two different classes because their names are the same. So, for example, Java language provides a string class, right? Places that in java.lang. One of the complaints about the string class is it doesn't do everything that you would want a string to do, right? So in other words, it only has methods that the Java language implementers decided should be in the string class, right? If you're using strings for some particular purpose, right, it would not be unusual to make your own string class, right, that can do different things than the Java string class, right? But now you have a problem, right? You want to call your string class string, right? But the language already defines one, right? And it's in java.lang, so it's always imported, right? So now you can't use your string class in the same program, or in any program, or in any Java program, right? Because its name is the same name as another class in java.lang. So your only choice, or one of your choices, is to not call it string, is to call it something else, right? But if you put your class into a different package, so for example, if you make the package called your, right, and you put the string class in that package, right, now I can use the two different classes in the same program, right? So whenever I use the Java string, I just write string. Whenever I want to use my string class or your string class, right, I write your.string, right? And so that lets the compiler figure out, or that lets two different classes with the same name exist in the same program, right? Because their fully qualified name is supposed to be unique, right? And so that's the purpose of using. That's one of the purposes of using packages. Now, does the language actually ensure that fully qualified names are unique? The answer is no, right? And so if you think about it for a second, it should be clear why the language doesn't guarantee that fully qualified names are unique, right? The only way that the language can guarantee this is if there was some central registry of every class that's ever been created in the entire world, right? So every time you make a class, you have to check with the central registry to make sure that your package names are unique, right? That's not going to happen. So instead, there's a convention. So the convention, when you create a package, is to take your domain name and reverse it, right? So the computing science domain name, the internet domain name is cs.queensu.ca. The package name for the CS department would be ca.queensu.cs, right? You just reverse you just reverse the order of the packages, right? And that's why you'll see in this course, everything's in the package ca.queensu.cs.sysq124. Now, why does this work? It's because all the internet domain names are unique. Because to make an internet domain name, you have to file that domain name with a central registry, right? So in other words, there's a organization somewhere that makes sure that internet domain names are unique. Okay. Now, what happens if you don't have your own domain name? Well, you just have to make something up. Right. So if you're an independent programmer somewhere, you're not working for anybody, then you can make up your own package names. Right. But you run the risk that your fully qualified name may not be unique. Okay, so that's packages. Now, what about classes? So a class, is an implementation of a type. Right? So when you want to make a new type, you just make a class or an interface. Now, the purpose of the class, right? So in a class, you're going to define the constructors, the fields, the methods, right, of the class, right? To make an object, essentially what happens is you make a copy of the class. I'm going to show you exactly what that means in a second, right? But you can think of a class as being the blueprint to make objects. Now, why do I want to make separate objects, right? Because every object has its own copy of all of the non-static fields. So if you create a class and it has a non-static field, then whenever you make an object, that object gets its own independent copy of that field. So that allows objects to have their own state, right? I can have two objects. They have different copies of the fields of the class. So object 1 can assign different values to its fields than object 2, right? So what does that mean? You can have a string, one string object that refers to the string that has that it represents the string hello, right? You can have a second string object that represents the string goodbye, right? You can have a third string object that represents something else, right? If you just had classes, you can't do that, right? Because a class, it only has one copy of its fields. Right? So if there were no objects, you wouldn't be able to have a string. You wouldn't be able to have a string that represents more than one string, which is not very useful, right? Here's an example using the point2 class. We're going to get around to implementing the point2 class today, a little bit later on. Right, so this slide here is trying to show you what happens when you make an object. Right? So here's point2. Right, so I'm going to make a variable of type called p. This is the memory diagram for these 3 lines of code. Right, so after this line of code runs, this is what memory looks like. Okay, so this thing called client, this is just where this code is running. Right, so I mean, don't worry about this line here. Right, when you make a variable called p, somewhere in memory, this variable appears. Right, now remember, this can appear anywhere. Right, so as long as this memory location is empty, right, you can make a variable and assign it to that memory location. Right, so it doesn't matter where you put this. Right, anywhere that's empty is fine. So here's my variable p, right? This is blank for now. We have new and we have point2, right? So in other words, we're going to use the new operator to make a new point2 object. The point2 constructor is going to run and assign the coordinates 1, 2 to that point. Okay, so what actually happens, right? When you first use the point2 in your program, the point2 class. Explain the significance of the static keyword. Yeah, static means that the feature belongs to the class. It doesn't belong to an individual object. So that will become clearer later on. But for now, it means anything that's static does not appear in an individual object. So if you have a static field, there's only one copy of that field, and it belongs in the class. It doesn't belong in an object. That's what static means. Where were we? Oh, the first time you use the point2 class in a program, that class gets loaded into memory. Okay. So down here is where the point2 class has been loaded into memory. So what's inside the point2 class? Well, it turns out there's a field called x and there's a field called y. Right? So there's a variable x, there's a variable y. These represent the x and y coordinates of a point. Inside the point2 class, you can think of these as not having any value. Okay. So conceptually, that's what it looks like, right? So the point2 class, right? This is just a blueprint that I'm going to use to make other objects. When the new operator runs, it allocates memory for a new point2 object. Right? So somewhere in memory, a point2 object appears. Right? How does this object appear? You take the class and you plunk it down here. Right? You plunk a copy down here. Right? So we take the class, I copy it, plunk it in memory somewhere. Right? That field's blank, that field's blank. So when this first happens, that field's blank and that field's blank. Somewhere in memory, there's an empty point2 object that's ready to be initialized. Now the constructor runs. So that's a constructor call. Right? The constructor sets the x coordinate to 1 and the y coordinate to 2. So that becomes 1 and that becomes 2. Now my point2 object has been initialized. So new can now finish running. Right? So remember, new is an operator, calls the constructor. Right? After the constructor finishes running, new returns. Right? And the value that it returns is the address of the newly created object. New returns the value 600. Right? So everything on the right-hand side of the equal sign, that's address 600A. Right? So that address gets plunked down beside P. Remember, P is a reference type, right? So P is a reference type variable. So the value that's stored here is the address of an object. So in this case, P refers to this point here. Now the same thing happens for Q, right? So point2 Q gets plunked down in memory somewhere, right? New runs to make a point2 object. So somewhere in memory, right? We take the point2 class and plunk down a copy of it somewhere, right? The constructor runs, fills in the coordinates to -3 and 8. So you get a -3 here and an 8 here. And then new returns the address of the object. So return 700, which is why the 700A appears here. Right, and then the same thing happens for R. The exact same set of sequence. The exact sequence of events happens for R. And notice what memory looks like now. I've got a point object here. It's got fields X and Y. I've got another point object here. It has fields X and Y. And I have another point object here. It has fields X and Y. Right. This X is different than this X here, which is different than that X there. Right. That Y is different than that Y is different than that Y. They all refer to different places in memory. Right? If I change this X, right, to say 3, then that changes to 3, but nothing else changes. Right? That doesn't change, that doesn't change. Right? So you now have 3 independent point2 objects. They all represent a different, they all represent a point having different coordinates. Okay, now we want to go about, we actually want to implement this point2 class, but we're not going to get around to doing everything today. Right? So when you, many types of classes represent values. So pretty, so many of the classes that we've used so far are what are called value type classes, right? So a string, for example, is a value type class. So an example of a value would be a name. You could use a string to represent a name. Dates, these represent date values, right? So there's a class called date that represents those. Colors are, you can think of colors as being separate values, right? So blue, red, green, and so on and so forth. Oops, sorry. There's more than one class in Java that represents colors, right? Our point2 class, right, represents 2-dimensional points, right? So they're an abstraction of a mathematical point. Right? So that's also a value type class, right? Things that are not value type classes, right? So the system and the math class, those are not value type classes, right? The math class is just a bunch of methods, right, that perform mathematical operations, right? So that's not a value type class. The system class groups together a bunch of stuff that's related to I guess the system that your program is running on, right? Again, not a value type class. So there's also classes that aren't value type classes, right? What else is there? You're working on the Wordle program right now, right? So the Wordle game class that you have so that you can run to actually see the Wordle game, that's not a value type class. The value type classes are very common. They're not the only type of class. But they're the easiest to start out with when you are beginning to program in an object-oriented programming language. Okay, now if I want to implement a value type class, right, I have to decide what information does each object need, right? So if I want to implement a point class for 2-dimensional points, it makes sense that there's a variable for the x coordinate. And it makes sense that there's a variable for the y coordinate, right? For a string, it makes sense that there's some sort of collection that can hold characters, right? Because a string is just a sequence of characters, right? Unclear how you would represent a date, right? So you might have a field for the month, you might have a field for the year, you might have a field for the day, right? Maybe. There's other ways to do it, but that would be one way to do it, right? So you need to decide what information needs to live in each object. Right? Once you've decided that, that gives you the fields for your class. So point2 class, right? I want a point that represents 2-dimensional real valued points, right? So in other words, a point that on the 2-dimensional real plane. Right? So what do I need to represent a 2-dimensional point? Well, I mean, the obvious way to do this is something for the x coordinate, right, and a field for the y coordinate. It's not the only way to do it, but I think this is the most obvious way to do it. So when you implement your class, it looks like this. Right? So this is what it starts out looking as. Right? Now you can ignore everything in blue for now. Okay? These are what are called JavaDoc comments. Right? For now, we'll ignore these. There's going to be a lab that tells you how to write these. There's our package, right? For right now, you can ignore that too, right? So don't worry about what package should I put my classes in, right? That's not the immediate concern. The immediate concern is, what does the class look like? It looks like this, right? So when you declare a class, that thing right there, or when you go to define your class, that thing there is called the class declaration. It's always the keyword class followed by the name of the class. Remember that class names should begin with a capital letter in Java. Public, I'll explain in a second. Right? So we'll explain what that is in a moment. You've got the braces. Now everything that belongs to the point2 class, it goes inside the braces. Right? And here are our fields. Right? So they look just like local variables in the method. They have a type, so double X and double Y, and a name. Right? The field names have to be unique. Right? So you can't have two fields called X, for example. Right? And then the fields, you can give them what's called an access modifier. Similarly with the class. Right? So I'm going to describe the access modifiers next. Okay, so we got public class point2, and our fields are private. Right? Okay, so that point2 class is an example of what's called a top-level class. So what's a top-level class? It's a class that's not inside of another class. Right? So our point2 class is not defined inside of another class. Right? So point2 is a top-level class. Now, if you have a top-level class, you can have what's called an access modifier. So the access modifier you can think of as being a visibility modifier. Right? So a public class, right? That class is visible to all other classes everywhere. So in other words, because point2 is public, right? Any class can use point2. They just import the package. They import it from the package that point2 is defined in. Right? So point2 is visible to every other class. Now, if public was not there, right? So there's no access modifier. Right? Then that's what's called package private access. That means that the class is visible only inside of its own package. So if public was missing from here, right, then you can only use the point2 class from a class that's also inside this package. If there's another class inside CA Queens U CISC 124 Notes Basics Geometry, right, then it would be able to use point2 if this wasn't here. You are in the package CA Queens U.CS. You can't use point2 even if you import it. Right? If you try to import it, the compiler will say it can't import it because it's not visible. That's what the visibility modifier or the access modifier means. Right? You only have two choices for top-level class. Right? It's either public or it's package private. For the time being, everything is public for our purposes. Right? The natural question to ask is, why would you want a package private class? Right? And so that's when you make a class that's usable. That's when you make a class that's used only by other classes in the same package. Right? So in other words, you make a class that you don't want anybody else to see because it represents something that's either not important for every other user, or it represents something that you want to hide from every other user. But it needs, but some other class in the same package needs to use it. Right? So we say that that would be, we say such classes are implementation details of other classes. Right? So it's stuff other people don't need to know. But for now, that's not important. Right? Everything for now is public. Your fields can also have access modifiers. Now, your fields, you get 4 choices for every field. Right? You cannot use these on local variables. Right? So if you have a method, you can't use these access modifiers. Right? So these are only applicable to fields. A private field means that the field is visible only inside the class that the field is in. So because we made X and Y private, you can only use the names X and Y to access these variables inside the point2 class. So in other words, someone who's using the point2 class cannot say p.x and get to that variable there. They can't say p.y and get to that variable there. Right? They have to go through a method instead if they want access to those variables, to those fields. Now, as you go down this list, the field becomes more and more visible. Right? So field private, only visible inside the class. Right? Package private, So that's no access modifier. Means that the field is visible inside of the class, and it's visible to any other class in the same package. Protected is even more visible yet, right? So it's the same as this. Field is visible inside the class. It's visible inside the package. It's visible to what are called the subclasses of the class. Right, so protected is used in inheritance. So that's part 3 of the course. So again, this is not important to us right now. Public means the field is visible to all classes everywhere, right? So if point 2, if X and Y were public, right, and someone had a point 2 object P, right, then that person could write P dot X equals 1 and P dot Y equals 2, right? So in other words, they have direct access to the fields. And that's the example of the index2 class that you were using, or that you should be using, sorry, that you used in assignment 1. Right. So in assignment 1, you had the row and column. Right. Those were public fields, and you could access those directly. Point 2 class, you can't do that. Now, the rules of thumb. So what access modifier should you pick for a field? Right. When you make a field, your first or your default action should be to make them private. Right? You can always make them more visible later. Right? So if later on you decide, oh, this needs greater visibility, right? Then you can change the access modifier. What you can't do is you can't make a field public to begin with, hand out your class for everybody to use, and then later on decide, oh, I can't make it public, I have to make it private. Because everybody who's used your class, their code will now break. Right? So as soon as you change the field back to private, everybody recompiles their program, all their existing code breaks because they were probably accessing the fields directly. And as soon as you make them private, they can no longer access them directly. So the default thing is to make everything private, right? Unless you have a field that represents a constant that's usable for everybody else, right? That makes sense for everybody else to have access to. Right? It's constant, so you don't care. No one else can change the value anyway. Right? So, for example, the math class has a constant big pi that represents the double value that's closest to the mathematical value of pi. Right? It also has a constant called big E that represents the double value that's closest to Euler's number. Right? Little e, if you've seen it in mathematics before. Protected fields, not important to us right now, but you'll see why they're used in part 3. So in a few weeks. Okay, that's the point 2 class. I think I'm going to stop there because otherwise I'm going to get like halfway through the next example and then we'll have to stop. So does anyone have any questions about the material in the lecture today? All right, I'm not seeing anything. Any assignment 2 questions? Is yellow? Yeah, is yellow. Is yellow. If you haven't done assignment 2, is yellow is the difficult method. That's to count the number of occurrences of a letter in a word. It's the only for if we decide to solve the problem with that. Yes. I don't understand the significance when we end up returning an array list of Boolean. You mean for counting the letters? You don't understand why it's useful? Right. So the array the list that you're returning is a list of true and false, right? It's true if the letter is yellow, it's false if it's not, right? So it's false if it's green or gray, right? To determine whether a letter is yellow, you actually have to count the number of times that one way to solve the problem is to count the number of times that a letter appears, both in the solution word or the answer word and in the guess word, right? So for example, suppose your guess is the word guess, right? G-U-E-S-S, right? So the letter S appears twice in the guess word, right? If your answer is the word count, right? The letter S does not appear at all in the word count, right? So by counting the number of times S appears, you know that the 2 S's in the guess must be not yellow, right? They have to be gray because they don't appear in the count in the answer. Right? it's actually a little more complicated than that, but counting the number of times a letter appears in both words is one way to solve the problem. Yeah, I'll post sample midterm questions later. Later today, I hope. Maybe tomorrow, it depends on how busy my afternoon gets. Any comments on what it'll be? Yeah, so on the midterm is basically everything up to and including probably lists. Probably not with sets and maps. So it'll probably go up to lists and that's it. Right? You won't have to make a class or anything like that, right? It's just basics of the Java language using strings and lists. That's it. All right, any other questions? Okay, so I will see you again tomorrow morning, I guess. Do I have office hours for you guys? I don't have office hours for you today. If you want to ask me assignment questions, you can try at 3:30 though. So I'll be on another. I have office hours for a different course, but I'll be around. So you can fire me an email and talk to me on Teams if you want to. Okay. All right. So thanks for coming out, everybody. Have a good day, and see you tomorrow morning.